Okay, this is Unit 1, Lesson 5, Characteristics of Absolute Value Functions. I now know, thanks to some of you that have spoken up, that if my video freezes, then I know that the audio is also frozen, and hopefully that doesn't happen, but I at least know that I need to be on the lookout for that. So hopefully I can get all the way through the lesson without having video freezing issues. I'm not totally sure what causes that, but fingers crossed. Okay, so for this lesson, we're starting with an explore in formative. So if you're watching this video from home, that formative should be unlocked for you. So you can go in and complete the warm-up for lesson 5. Just go ahead, log into your formative account and do that. And then if you're doing this after I have already graded it for everybody else, make sure you send me an email letting me know that you have completed it. Otherwise, I don't know that your work is there for me to grade. Okay, so just you can pause this video and go hop over into formative and take care of your warm-up. So what's like the learning target and success criteria for this lesson? So learning target is very broad. Understand the characteristics of absolute value functions. How will we know if we understand the characteristics? Well, you can describe the characteristics of an absolute value function from a graph. And what we'll be doing in class is I will hand everybody an absolute value graph. And as we go through each of the characteristics and I do an example, then you will be working on your classwork to state the characteristics for your particular graph. Now, if you're doing this from home, then what I might do is provide a graph for you to work with so that you can participate in that and get your classwork grade for that from doing it at home. So check and see if I have posted something. If I haven't, send me an email right now and say, Ms. Taylor, I want to do the classwork for lesson 5 and there's no graph for me to work with. Okay, I can graph an absolute value function given its characteristics. That's going to be our activity at the end. And then real life problems, we may or may not get to that. I did not include that in this particular PowerPoint, and there is a reason for that, so I'll address that in class with the real life problems with absolute value. All right, so there are 5 characteristics of absolute value functions, and this slide is just simply going to list them. So I might give you the notes outline that I've been giving you so that you know, okay, this is a list. You want to take everything down because that structures the lesson, and then we'll go into each characteristic in detail as we move through the lesson. First one is the vertex, okay? And because this class follows geometry, the vertex should be kind of self-evident. You know, the vertex in geometry is where you have the endpoint of 2 rays, and so your rays go off. And so the vertex of an absolute value function would be where the 2 rays meet. It's the same definition as from geometry. The axis of symmetry. Okay, so think axis is a line. Okay, like the x-axis and the y-axis, so the axis of a line, and then symmetry has to do with it being symmetrical. So the axis of symmetry is a line where the graph would be symmetrical on either side. So even if I've never defined that for you, we want to become better at piecing together the meaning of words that we know. Where the graph increases or decreases, and that simply means where it goes up and where it goes down from left to right. So in math, we do go from left to right. That's the order of the numbers on the number line. In English, we read left to right. I know not every language does, but in English, we read from left to right. So when we're talking about a graph increasing or decreasing, we're talking about as we trace the graph from left to right, which I think is on the video the right direction. I'm having to do it backwards, so I'm sorry if the program flips it around and I was going from right to left, but it should be from left to right. Where the graph is positive or negative, and the definition for that is where it is above the x-axis or below the x-axis. So it's positive if it's above and it's negative if it's below. It pretty much has to do with the y-coordinates, if the y-coordinates are positive or the y-coordinates are negative. And end behavior, if you heard that, that was a cat. Doesn't seem very happy. The end behavior. And the end behavior is whether the graph points up or down at the ends. So you have stuff in the middle, like we have the vertex in the middle, and later in this course when we're looking at polynomials, you might have a graph that kind of goes up and down a little bit. But at the end, it's either going to point up forever or it's going to point down forever. And it might do like one side points up and the other side points down. But that's what end behavior is, whether the graph points up or down at the ends. So those are the 5 characteristics that we will be covering. All right, so the vertex question, what is the vertex? Answer, it is the point at the bottom or the top of the graph. It is the point where the 2 rays meet. And so if I look at this, we have a ray and we have another ray, and the endpoint of those rays, that is the vertex. It's exactly the same thing that it was in geometry. And so the vertex for this graph is the point 4, -1. You can also get the vertex by looking at the transformation. So if, sorry, I'm just rewriting that a little bit neater. There we go. So if you think about this graph went right 4, down 1 from the parent function where the vertex is at 0, 0, you can also get the vertex that way by looking at the transformations. Now, the axis of symmetry, before we really talk about the axis of symmetry, I want to do a quick discussion about vertical lines. So vertical lines are lines that go straight up and down like that. They're actually not really common in algebra. And the reason they're not common is because of this right here. They are actually not functions, and functions have to pass something called the vertical line test, and a vertical line is not going to pass the vertical line test, and so we don't see them that often. Now, what's interesting about them is that they take the form x equals instead of y equals. So most of our lines would be of the form y equals mx plus b. And that would be like your typical lines that are functions. A vertical line actually takes the form x equals, and then it would have some number for whatever the x is equal to. And what that means is it doesn't matter what y is equal to, x is always going to be that number. So for example, it says sketch the graph of x equals 4. So I would look at my x-axis and I go over 1, 2, 3, 4. Okay. And then the graph of x equals 4 would be the vertical line at x is equal to 4. And just so that makes sense, every single point on that line, the x coordinate is 4. So we have this could be like 4, 3, and this one might be 4, 2, and this one might be 4, 0. And so the x coordinate is always a 4, hence the equation is x equals 4. Now you might be wondering, well, how could I tell the difference between that and whether you just wanted me to plot like a dot on a number line? Context of the problem is the answer. So if you're dealing with the xy plane and you know you have an x-axis and a y-axis, and mine's tilted funny, but then you know you're dealing with a vertical line versus just a point on the number line. All right, so axis of symmetry, question, what is it? Answer, it's the vertical line through the center of the graph where the absolute value function would be symmetrical. So to look at this example over here, the axis of symmetry is actually, oh, I wanted to change the color. I didn't want it to, yeah, there we go. The axis of symmetry would actually be that line right there. And I'll let you kind of digest that for a moment. The axis of symmetry goes through the vertex. And so, yeah, it goes through the vertex. So if you know the vertex, then you're already halfway to getting the axis of symmetry. For this particular problem, it would be x is equal to 4, would be the equation. Now, usually when I'm graphing it, okay, if we're dealing with the graph of an absolute value function and we're talking about the axis of symmetry, a lot of times what we'll do is we'll make the axis of symmetry dashed. And the reason we do that is to indicate that it's not part of the actual graph. So in this case, the graph we're talking about is the absolute value. And then the axis of symmetry is a characteristic, it's a feature, it's a useful thing to know about the absolute value graph, but it's not part of the graph itself. So we'll make it dashed for that reason. So that's what your axis of symmetry is. And because it is a vertical line, your axis of symmetry will always take the form x equals a particular number. So at this point is where we'll take a break, and on your graph, so hopefully I can remember to have some kind of graph for you to work with if you're watching this from home, state the vertex and the axis of symmetry. Okay, state the vertex and the axis of symmetry for your graph. Okay, so I hope you paused the video and allowed yourself to do that. And if you need to go back and rewind the video and re-look at my examples, it's one of the advantages of having a video. You can't rewind the live class, but you can rewind a video and say, I need to see that again. Yeah, so that's one of the advantages. So hopefully you've worked through that. Now, the next slide, this is going to lead into our increasing, decreasing, and our positive, negative. So when you are answering a question like this, you need to be able to state an interval. So for example, if you were going to state like when you were sleeping, you would state an interval of time. I slept from 10 p.m. to 5 a.m. And so you have like a beginning time and you have an end time, and you state the interval. When you are stating where a graph is increasing or decreasing, you are going to state an interval. Like, so you're going to give like kind of the region where the graph is going up or going down. Key idea, always, always, always use the x coordinates when you are stating intervals. You never state them ever from the y coordinates, okay? So you don't say it goes up from, like, just, I don't even want to confuse you by trying to say it. Okay, you always, always, always use the x coordinates. Now, there is a time when we talk about the y coordinates, there are questions that you might be asked, but not if you were stating an interval. Now, the reason for that is because when we're dealing with functions, you can't repeat your x values. So if you remember studying functions from Algebra 1, it has to pass that vertical line test. And so you can have repeated y values, but you can't have repeated x values. So if you try to state an interval with the y values, you open it up for the possibility that those y values could be repeated somewhere else, and maybe the graph isn't increasing or decreasing there. But if you use the x coordinates do not ever repeat, and so there is no room for confusion there. Now, there is a thing called interval notation, and prior to recording this video, I just had an hour-long conversation with one of the other Algebra 2 teachers to try to make sure that we are on the same page with this. And we agreed that we needed to teach you interval notation because the curriculum does, and it might be one of the things you need for your exam, but that we weren't going to emphasize it. So I'm going to go over it. I want you to kind of grasp what you can grasp. If it makes beautifully clear sense, then yay. If you feel like it's a little bit confusing, let me know, and we will try to keep emphasizing it. It's actually not hard at all, but it does, like with most things, it does take some practice and some getting used to. So here's the deal. So you might have like a smaller number. Oh gosh, there's what those rogue infinities went. I was trying to type infinities and I think my cursor was in the wrong place. Okay, so there's these are rogue and rebellious infinities right Anyway, so just like with sleeping, you might have the time you fell asleep and then the time you woke up. So you would say, I slept from 10 to 5. And the number that you state first would be the number that comes first, and the number, like, so I went to bed at like 10, and the number that comes second would be the number that comes second. I got up at 5. Most people would not say it in the other order. They wouldn't say, if I said, how did you sleep last night? You'd back it up and be like, well, I got up at 5 and I went to bed at 10. I mean, I guess you could, but most people would do that in the order that it happened. When you're using interval notation, it has to be in the correct order. So the smaller number is on the left and the larger number is on the right. And I put them in parentheses. They are always separated by a comma, and but the parentheses aren't always there. And then these are just messed up infinity symbols. Okay, just ignore them. So you use parentheses if the number is not included or if you're using an infinity. Okay, so there's a place for infinities here. So in this case, I have them in parentheses because I needed to demonstrate it in something, but parentheses are used if the number is not included, and you use brackets if the number is included. Okay, so brackets if it is included. Now, I think it might be better to show you an example. So I've got 3 examples that I'm going to show you right here. So the first one, it has -4 to 7, and you'll notice that we have a parenthesis on one side and we have a bracket on the other side. So I'm going to show you what that means. Okay, so if I have a number line, and we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so we'll just put some stuff on there. Suppose this is -4, okay? And then I would go, I'll like kind of put through this with the pointer, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. Okay, and so we start at -4 and we go to 7. And just like when you're sleeping and you would say, I slept from 10 to 5, you mean 10, you mean 5, and you mean everything in between. And so what that means is -4 to 7 and everything in between. Now, because there is a parenthesis down there, what that means is that the number 4 is actually not included. And because there is a bracket used on the 7, it means that the 7 is included. Okay. Now the analogy of the time that you're sleeping it kind of breaks down with that. But yeah. So I think you guys know from before, like whether or not a number is included or not. So if you see a -4 with the parenthesis, and then you see like a 7 with a bracket, it means -4 to 7. You're stating the interval. And then in this case, the -4 is not included and the 7 is. All right. Now the next one there says -5, 0, and you'll notice that that looks like an ordered pair. Okay. And I do want to address that briefly. Let's do the interval notation though. Oh. There we go. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. And so we might have -5 is in parentheses, so it's not included. And then we have -5, -4, -3, -2, -1, 0. And everything in between. And because both of them are in parentheses, it means neither of the endpoints is included. We mean everything from -5 to 0, but not actually the -5 and the 0. Now, what you should be thinking at this point, if you're paying attention and you're not just, copying stuff down, is you should be looking at this notation right there and saying, Miss Taylor, I thought the -5, 0 would mean the point -5, 0 on the coordinate plane. Yes, that notation can mean both things. It can mean the ordered pair, -5, 0, or it can mean the interval from -5 to 0 on the number line. How do you know which one it is? By context. They are identical notations. So if you just saw it out of the blue with no context, you would not know which one it meant. You would have to make some kind of assumption. But you'll know what it means because of the context in which the notation is used, similar to how you know whether or not, like let's just say, we could use the example of where, like where is my hairbrush, and where, like wearing clothes. Both of those sound exactly the same, but we generally don't confuse them when we're speaking because of how the word is used and the other words around it. So while those notations are the same, it's not usually an issue because of the context of the problem. And then let's look at this last one. This one has the infinity, so it has 8. Now remember, you always have to have the smaller number on the left. So this one is going to start at 8. And notice that it has the infinity symbol. I was trying to type that when I typed those extra ones, okay? So we have 8, and the 8 has the bracket, so it's included. And then infinity is that way. Okay, infinity is not a number, it's a concept. It's the idea that like your numbers keep going. And so the upper number on this is infinity. What we do is we just shade it going to the right and we never stop. And you use a parenthesis when you're dealing with infinity. And you could also see negative infinity. If you saw a negative infinity, then it would be going to the left because that's where the numbers are getting smaller. So you have infinity where the numbers are getting bigger and negative infinity where they are getting smaller. So that's essentially what interval notation is. It just takes some practice, and with everything in Algebra 2, I never feel like we have quite enough time to practice it. I don't think it is an absolutely critical thing that you know and understand right now, but what we'll do with the examples is we're just going to keep practicing with it, and I think the pieces will fall into place. So for our next one, stating where a graph increases and decreases. So for this, I'm going to try to use the highlighter. I don't know, it's been temperamental with the highlighter, but you do want to label this. So if you're going to say like increases and decreases, you do need to label which is which. You can't just throw them out there. Okay. And if I look at where this graph is increasing, remember increasing means going up. Okay. Here is where it's going up. But remember that we're not supposed to state the y coordinates. So that goes back to that last slide. When you're stating the intervals, you always, always, always state it on the x coordinates. So what I'm going to do is kind of take this region and extend it to the x-axis. Okay, from both directions. It could be below the x-axis or above the x-axis. And look at where my x-axis is highlighted. The highlighting starts at the 4 and goes that way. Okay, that's like so sloppy. Okay, it starts at the 4 and goes that way. So 4 is the smaller number. So 4. And then because that graph keeps on going forever, it's going to go to infinity. The infinity has the parenthesis. Now, with the 4, do you use a parenthesis or do you use a bracket? And again, I just before recording this lesson got off the phone with another teacher because I have seen it done both ways, because technically the 4 is at the where the vertex is. It's actually not going up or down. Like it's either both going up or down, or it's neither going up nor down. I have actually seen both. I have seen textbooks, and so had the other teacher. The other teacher had looked it up on College Board and said like there's actually both would be correct here. So I tend to use a bracket. The other teacher tends to use a parenthesis. We both have our reasons for it. I'm going to go ahead and use the parentheses just so I'm consistent with what the other teachers are doing. And because there's a math reason why that works as well. Because technically right at this point here, it's it's not going to make any sense. So the derivative is 0 at that point, but you guys don't know what that means. Okay, for decreasing, go find my highlighter. Okay, for decreasing, it is this chunk over here. And again, we are going to reference this from the x-axis. So I'm going to kind of drop it down and look at the x-axis and bring it up. You got to be mindful of both sides there. And keep in mind with this one that it is going out there to negative infinity. Sometimes I will see students do this. Do not write this down, okay? Do not write this down. They will say, "4 to negative infinity." And I used to teach college algebra, and I would see college algebra students, so they're taking a college level class, and they would do that. The problem with that is that it's got them in the wrong order. Okay, so remember the smaller number has to be the one on the left. So you need to look at your number line and see what's on the left. So this one actually has to start at the negative infinity and go to the 4. Okay, and it has to be stated that way. So I'm going to take this and I'm going to draw a line through it. Okay, and you need to make sure that you have them in the right order, which is where graphs can come in really, really handy. So there's our increasing and our decreasing. Now, if you're very uncomfortable with that, if you would prefer to say something like it is increasing from 4 to the right, or to the right of the 4 and decreasing to the left of the 4, I will for now accept that, but try to do it with the interval notation. And then if you feel like the other way you could say it is you could say it's increasing if x is greater than 4 and decreasing if x is less than 4. Both of these notations are completely correct. They're completely mathematically correct. So you can state it however you want for now, but I'm going to keep coming back to that interval notation because I think we're supposed to be covering it now in Algebra 2. I'm making a face because I did this whole slide and accidentally fast forwarded, so I'm having to re-record this slide. I had all this beautiful highlighting and everything done. So anyway, okay, so stating where a graph is positive or negative. So we need to remember what that means. Positive just means above the x-axis, negative means below the x-axis. And just like with increasing and decreasing, I'm going to label my answers, okay, positive and negative, so that I know which answer goes with which piece of that. And I'm going to use a highlighter. So we're going to employ color in helping us to see where the graph is positive or negative. So using the yellow highlighter, above the x-axis would be this piece and also this piece over here. And then we'll use a green highlighter, and this would be our negative piece. Okay, so don't overthink that. Positive above, negative below. And now I'm a big advocate of do the easy part first, or if there's one part that trips you up, do a part that seems easier. There's nothing that says you have to do problems in a particular order. And when you're doing a multiple choice test, you can actually be really, really savvy with those multiple choice questions by playing problems this way. So for the negative, let's say just hypothetically, you're a little bit thrown off by the fact that there are 2 intervals and you're just not quite sure what to do with that. Start with the negative part, okay? So remember that we have to reference everything from the x-axis. So we have to look at where the graph is becoming negative. And we've got the point 3 and 5. Okay, so it is negative between 3 and 5. And you do want to use parentheses there because at the 3 and at the 5, it's actually 0. So it's not actually negative. It is negative in between the 3 and the 5. So you might be thinking, but that looks like the 0.35. Go right 3, up 5. Yes, it does, except we know what the directions are stating, and we know that that kind of an answer would not make any sense with those directions. Now, with the positive, again, we want to make sure that we're referencing this from the x-axis, okay? And so we're looking at it from the x-axis. It's like we're dropping it down to see where on the x-axis we are. Now, this interval over here, like because the graph goes on forever, we're dealing with a negative infinity. So our first interval would start at negative infinity and it stops when you get to the 3. And then we've got over here positive infinity. So the second interval starts at 5 and goes to positive infinity. Now, there's a symbol that you are supposed to put in between those intervals. And if you have never studied what's called set theory, then this is going to just be a very random symbol. But it's this symbol right there. That is the symbol for union of sets, okay? It's a union of sets, and what it pretty much means is both, okay? It means both sets. So if you think about marriage is the union of two people, and then some wedding ceremonies, ceremonies, they'll talk about like the union of two families coming together. And so instead of just two separate families now, because of this marriage, now you have one bigger, and we hope happy, but sometimes not, family, because now we have like lots and lots of in-laws and stuff. So think of like union as being both, and what you're saying when you use that symbol there is you're saying it is this chunk and also this, like both of these are where the graph is positive. All right, so I do have to stop the video and move on to the next slide because that got messed up. It's okay. And you were all back, and it's wonderful. So on your graph, state where your graph is increasing, decreasing, positive, and negative. It is possible with an absolute value function that it might not be positive anywhere, or it might not be negative anywhere. That is possible. Now, because of an absolute value graph, because of the shape of the graph, it will be increasing and decreasing at some point. Now, not all graphs are, like some graphs are always increasing, some graphs are always decreasing, but absolute value does change direction. So you should have an answer for increasing and an answer for decreasing. You might have an answer for positive and negative, or you might only have one of them. Okay, so pause the video and do yours out, and then unpause the video. Okay, now if you have something that is always positive or always negative or always increasing or always decreasing, pretty, I don't know if you can hear that. I'm apparently getting messages from somewhere. What you're dealing with is your interval goes all the way across the whole number line. And the way that looks is you have negative infinity, comma, infinity. And that's another way of saying all real numbers. Okay, it's another way of saying it. It pretty much means everything. And my handwriting is horrifying. That's the funny little R. That's all real numbers, and so this is negative infinity to positive infinity. So if you got one that looked like that, then that's how you would answer it. Okay, the last topic in this is end behavior, And pretty much what I said earlier was that end behavior is what the graph does at its ends. So graphs can do stuff in the middle. We don't care about whether it goes up or down or has break, like, no. We just want to know which way is it pointing when you get to the ends. So pretty much basically what you need to state is which direction the graph points on the left and the right. You have to state the side and the direction both. Now that might seem stupid right now or kind of silly because absolute value they will be the same. So with the absolute value, they will either both point upward or they'll both point downward, but we will look at some graphs later on where one of the sides points up and the other one points down. So you have to say which side you're talking about and which direction. Side gives you the X and the direction it points gives you the Y. So that's how we kind of separate them. So for this example, I have the left side of the graph and I have the right side of the graph. So we have the left and the right. And what we can say is that the left points up and we would say the right points up. Okay. And that's really all that we're looking for with end behavior. With absolute value, you are going to have the same answer for both. Left and right are both going to be the same thing. Sometimes students will say left and right both go up, or they'll say both are up. Just keep in mind that not every graph will do that. Like a line, like one side points down and the other side points up. So you do need to specify the side and the direction. Now there is one more little blurb on this, and that is your textbook may use a different notation. At the time I am recording this, I have not checked to see what the textbook uses or what the online book is going to mark as correct, like right or wrong. I will check that out in the near future as we get closer to presenting this lesson. But your textbook may use a different notation using an arrow and lots of infinity symbols. It's not a hard notation to learn, but you do, like, I do need to teach it to you. So let M know if this happens. M is me. Let me know if that happens, so that I know I need to go in and hand grade some responses, like the textbook might mark it wrong, or if it might be beneficial for me to do a quick little lesson on what that notation is. Don't copy stuff off of the internet or an app or anything, just because you want to take a shortcut. If you don't know what it means, tell me that you don't know what it means. I know that there's another notation out there. I'm totally okay with this. I know the other algebra teachers are totally okay with this, and we'll take it from when we know a little bit more about your final. All right, so on your graph, take a look at your graph and state the end behavior. Okay, so state what it does on the left and what it does on the right. Pause the video and finish that out. Okay, so what do we have left? We are going to try to do an activity in class, at least at the time of this recording. Now, if we lose a lot of instructional time or something, we might not be able to do it. But here's the activity: identify, swap, sketch, and compare. So what I want to do with this activity is I want to give you practice identifying the characteristics of the absolute value and also getting that second success criteria in, where you can sketch a graph based off of the criteria. So you will be given a graph. Okay, and then you will identify the vertex, where the graph increases and decreases, and where the graph is positive and negative. Okay, so you're going to identify those things, and what I will try to do is put together like a little card that you can just fill out. Okay, like this is what my graph does. And then you will swap descriptions with another student. Now, I don't know how we want to do that. Like, I want to be able to keep track of what graph, like who has what, and then be able to swap back. Okay, so you're going to swap the descriptions with another student, and then you will get like you'll get a set of descriptions. You're going to try to graph the absolute value function based on the description provided, and your partner is going to try to sketch the absolute value for your graph, like based off of what you provided. So hopefully you provided the right stuff. Hopefully the person who gave you stuff provided the right stuff. Then you're going to compare your sketch to the original graph and to see how you and your classmate, how well you and your classmate did at describing and sketching the graph. And we'll find some way to kind of evaluate and share that and discuss if you got a fact wrong or you interpreted it wrong with the graph. Remember, we're not afraid of getting stuff wrong as long as we can learn from it. So now, if you're watching this from home, you'll probably get a pass on this activity because it's not the kind of thing that you can do at home. But I want you to know what's happening in class, even though you're not there. All right, so that is lesson 5 on characteristics of absolute value functions.